All right, welcome back to operating system. So yeah, final exam review. What shall we do? It is up to you. Any requests other than that, I will start flipping and you can stop me. Yep. 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 The compare and swap? To just implement a spin lock or something like that? All right, let's see how much I remember off the top of my head. All right, so, whoops, that is not for you to see. All right, so, compare and swap. Takes a pointer to an int, some old value. So that's what compare and swap looks like, and this is an atomic function, so it either all happens at once or it doesn't. And what it will do is load the value that is at this location and then see if it is equal to this old value. If it is, it will swap that atomically and swap the value and put in new value. And it always returns whatever it currently read. So like atomically, it would do essentially current value equals, dereference P, and then if old val, whoops, that's like Yoda conditions. Check if current is equal to old val. Then P equals new val. Return, actually it's going to return current anyways. So that's essentially what compare and swap does, and that all happens atomically. So if you make your lock, just your lock function something like this, lock, it's just a pointer. Whoops, I should call it mutex, whatever. So you could have while compare and swap M0, 1, like that. So that could be my lock function because all it's going to do is try to atomically change the value 1 to change the value 0 to a 1. And if it's able to do that, then it will return 0 and it'll break me out of that while loop. So if I break out that while loop, I know I atomically changed the value from a 0 to a 1. And that's the only thing I need, because after the lock, I should be the only one that's actually reading this location that can, or writing to this location that can change it. So if I want to unlock the mutex, I just change it from a 1 back to a 0. But we need the compare and swap so we can atomically change this value and make sure that only one thread can change this value. Because if two threads are fighting for it, well, if they both call it at the same time, because it's atomic, only one of the threads will actually change it from a 0 to a 1 and not both. Because before we had the implementation where we just checked over and over again, and then like we read it, and then we could get context switched out, they could read a 0, and then they both write to it, so they both pass by it. So does that answer your question? So it will always continuously try over and over again, and it will exit this function if it finally changed it from a 0 to a 1. And it will only do that once.
So it will do that, and that means that it has the lock.
Yes. Yeah, if it does it, it means you have the lock. I'm the thread that changed it to a 1, so it is my lock now. Okay, yep. Sorry? Yeah, so if it successfully changes it from 0 to 1, then that function returns 0, and then because while 0, it actually breaks out of it. And for anything else, it return 1, and then it just keep on trying over and over again. Okay, anything else, or should we start flipping? Like this, flip.
How like detailed, like, so for example, the two variable, like with the guard, the actual lock, like how in depth do we have to know that?
The implementation with the guard and the lock,
The lock and the actual lock.
not that much, I guess, but the guard was essentially a spin lock, right? If I,
The guard is the spin lock, and I kind of
Yeah.
see it as like it makes the entire thing atomic.
yeah, so has mutual exclusion, no data races. You'll get some data race question, I guarantee it.
But it's not going to be like, oh, write, like, describe like how this lock works.
Probably not. Probably, yeah. It wouldn't be like describe how this lock works. If there would be, it's like, oh, when should I use a spin lock versus a mutex? That's valid. Yeah, all right. So, short answer, skip this. So, buddy allocator, we kind of just went over that. Explain the purpose of condition variables, concept of RAID 5, virtual machines, that won't be on it for you. Kernel mode stuff, I think you had a question like that on your midterm.
Sir, by the way,
Yeah,
virtual machines that won't be on the final.
no virtual machines for you. You are, all right.
Can we assume that stuff that wasn't, like stuff that was on the midterm, or like content that was covered on the midterm won't be covered on the final?
No,
Is it mutual exclusion?
it is not mutual exclusion. The final will have processes on it because I can't write code without it being a process if I run it. And it'll probably have virtual memory on it because everyone likes virtual memory. And it's a,
No scheduling without the midterm, I guess.
yeah, so stuff I put on the file is generally stuff that I want to make sure you know, and the scheduling question average was super high, so I don't need to put it on it. So page replacement, you will probably get a question on that because I haven't tested you on page replacement yet. So should I do page replacement? Probably not, probably a waste of time. Hopefully everyone knows page replacement. So just practice it if you haven't. All right, virtual memory. We should probably do locking. So let's skip unless someone yells at me to stop. So virtual memory, processes and threads.
Wait, did we test threads in the midterm?
No,
Not really.
no, not at all.
Should we take a look then?
I think we kind of reviewed that one. Let's do locking first. Everyone locking?
Yeah.
All right, locking, sweet. So, consider the following code. We have 3 threads, each executing their own function here. That's what the setup will be. And in thread 1, it locks mutex 1, then mutex 2. In thread 2, it locks mutex 2, then mutex 3. In thread 3, it locks mutex 3, then mutex 1. So if I have 3 threads, each running their own function here, question numero uno.
What? There will.
It doesn't even ask if there will be a deadlock. It says explain a deadlock.
Ah,
So give me the deadlock condition here.
so basically every thread is trying to acquire a lock that another thread has already acquired.
Yeah, so specifically, what's a deadlock condition here? Yeah.
So when you have 2 threads and each of them hold a lock, but then now they want each other's lock, and
Yeah, when neither can make progress, but what is the situation with these 3 threads that you can give me where no threads can make progress anymore?
Thread 1 wants lock 2, and thread 2 wants lock 3, and thread 3 wants lock 1.
So they have to execute the instructions from the top to the bottom. So do you mean thread 1 acquires mutex 1, and then thread 2 acquires mutex 2, and then thread 3 acquires mutex 3, and then we're screwed?
Yes, we are.
Yeah. So is that the condition everyone wants to agree on?
Yeah.
So if thread 1, it locks M1, then thread 2 executes and it locks M2, then thread 3 executes and it locks M3. So if we are at this point, now this is our condition with a deadlock because, well, thread 1, it is going to try and execute this line, tries to lock mutex 2, but it can't get mutex 2 because thread 2 has it. Thread 2 wants to execute this line. So it tries to get mutex 3, but thread 3 has it. And then in thread 3, it's trying to execute this line to try and acquire mutex 1, and it can't do it because thread 1 has it. So none of these threads can make progress anymore, therefore they are all deadlocked. So, good? All right, fix it.
Switch the order of mutex 1 and mutex 3.
The order of mutex 1 and mutex 3, where?
In thread 3.
In thread 3.
Not sure if that will work.
All right, so just swap these 2 lines.
I think so.
Will that
And the ones where they unlock.
and these ones? All right, will that work?
I hope so.
Anyone with an argument as to why this would work? And specifically, what is the name of the deadlock condition we are eliminating for bonus points? So we can verify that this kind of works. So if we had the case where thread 1 executed, then thread 2 executed, and then thread 3 executed, if we swap the lines, thread 3 can't make any progress because essentially it would be trying to acquire lock 1, so it can't make any progress, but the other threads could make progress, and doesn't really matter. One's going to have to execute at some point. If T1 executes, well, it would lock M2. Well, it wouldn't lock M2, so we actually only have one thread that can execute, and it is T2. It would lock M3, and then it would do whatever it needs to do, and then it is still able to run, and then eventually it will unlock them both, and then at that point, thread 1 would lock M2, then eventually it would execute, and then unlock both of them, and then finally thread 3 could run. So it seems to at least alleviated that scenario. So, anyone for explaining what the condition is we're eliminating here? Or does this work? Seems to kind of work.
How
So,
to solve the deadlock?
so why does this work? Explain why this works.
Why there's no deadlock?
Yeah. Why this fix prevents any deadlocks. Yeah. Yeah, it breaks the circular weight condition because every thread acquires the mutexes in the same order. So we always do in order 1, 2, 3. So if we always acquire them in the same order, In all threads, we break circular weight, therefore we do not have a deadlock condition. What's another way to fix this?
Use one mutex on every
You have to use 2 mutexes.
Wow.
Yeah.
Either tri-lock or like
Yeah, the tri-lock one where I try, if I don't get it, I give it up, yield, then try and get it, or then get again, try again. What deadlock condition am I breaking if I do the tri-lock example, or tri-lock solution?
you're not blocking other threads from having forward.
There's a special name for it. Yeah. No, not preemption, because preemption is just I take a lock away. We didn't have that as a solution.
Name for what, sorry?
For if we have the tri-lock solution here, where if we don't get the other one, we give it up. All right, spoiler, it's just called hold and wait. Hold and wait is the solution. So either those are the 2 main solutions we have. So either we acquire them in the same order, break circular weight, or do the tri-lock, and we get rid of hold and wait. All right.
Wait, that's it?
Yeah, that was it for the question.
Oh.
So explain the deadlock condition and propose a solution. So if you just swap 2 lines, easiest 6, hopefully it should be the easiest 6 marks you got if you could explain it. You just had to swap 2 lines. So, semaphores. So here, I even hid the solutions. So this is very pro-level hiding. So we have this following code. We have 8 total threads. We have a semaphore. We have an initialized sema function where the value is given as a blank. And in a run function, we are told that there is this initialize everything function that we only want thread 0 to execute. And then we want every single thread or core to execute its own initialize thread function only after, and I repeat, only after initialize everything has run. So, assume we have n threads. You set up to start executing the run function. Each thread receives a unique thread ID. In addition, the initialize sema function executes before any threads get created, so it's safe to initialize the semaphore. So, question 1 for this part is using a single semaphore, enforce the synchronization constraint specified in the comments. You may add code or pseudocode or explain it or do whatever. Try to make a solution that supports any number of threads, assuming thread 0 always exists. For a maximum of 7 points, you may cheat a little bit and use that total threads and assume it's the actual total number of threads executing the run function. So, how would I use the semaphore to make all of these comments true? I want initialize everything to run only in thread 0 and then before any other thread calls initialize thread. So first step is see basics. How do I make only thread 0 execute this initialize everything function?
If thread ID is 0, then
Yeah, if thread ID is 0, so boom. All right, part 1. So what about for the rest of it?
it takes the wait, semaphore?
Yeah, we just have one semaphore. So usually what is the easiest thing to place first? Okay, wait, first, does everyone remember what a semaphore is?
It's kind of like a lock, but fancier.
Yeah, semaphores are basically just an integer value, and I get to use 2 atomic operations on them: post, which will atomically increment it, and then wait, which will atomically decrement it if it will become a non-negative number. So if the current value of the semaphore is 0, it will block until another thread goes ahead and posts it back up, so it can actually decrement it without it going below 0. So, do we remember what function is usually the easiest to place first? The weight first. All right. What do I want to weight? Well, where should I place my weight? After initialize everything. So let's assume I just have brackets here. So you want a sem weight here.
No, like outside the if.
Outside the if, like here.
I'm a little confused on the question.
So we want only thread 0 to execute this function. And then after thread 0 executes this function, any threads can execute this. Yeah. Yeah.
We let thread 0 take the lock in the if statement, and then out of the statement we have every
What do you mean by you let thread 0 take the lock?
I mean like take the semaphore, or what does that mean?
I don't know what take the semaphore means.
Post, or wait, what does the post do again?
Increments it atomically. Increments the value.
Then try and have it post then.
Oh. Not quite. Any other suggestions?
You want thread ID 0 to maybe set it to 1 initially, and then have thread ID 0 decrement it, and now the rest, and then put a weight,
So
put a post on the rest.
So set its value to 1, and then,
Like either way would work. You have to reverse all the logic, right? Since you're only using one semaphore, so you could.
so where do I want, tell me what else should write. I wrote the value is 1. Value is 1.
After initialize everything.
Ap-
Okay, actually, let's set to 0 initially.
All right, now we're setting it to 0.
After initialize everything, you post. And then all the other threads should, before doing anything, wait.
How do I make all the other threads wait before doing anything?
Put a wait call before.
Like wait here?
Yeah. Yeah, that wait, so because then thread 0 will be able to do its thing and then post it. And then wait, and then at the end of all that, another post after all the stuff that you want. Like after initialize thread or whatever. It's like the critical section right now. Wait, I'm confused. Okay, so you want thread 0 to run and initialize everything, and what are all the other ones doing?
Nothing?
Nothing. Okay, let's start again. So the way to think of this is without setting the initial value or anything, usually the first thing to place is the sem weight function. So in this case, what do I want to wait? I want all the other threads that are not thread 0 to wait until thread 0 calls this initialize everything. So in that case, just to be explicit about it, I could have an else, and then in the else, I will have my sem weight So now is when it's probably appropriate to think of our initial value because that could execute first. So right now, if the initial value is 1, that is probably bad because it could be the case that thread, 3 executes this function first, and then, well, it's not thread 0, so it goes into this else, and then it does a wait. If the current value is 1, it will change the 1 to a 0 and just keep on going. And then thread 3 calls initialize thread, and that happens before initialize everything, so that is bad. So that probably means that our initial value should be 0. So in this case, so we have a post here.
Can you atomically increase by more than
You can call a post multiple times.
Okay, so let's do that.
Yeah, so just like for num threads.
Okay, that's the part I wasn't.
So that should work. So if thread 3 or thread 4 or whatever makes it here, then it will wait. The current value is 0. None of them can progress. And then only thread 0 can execute. It will call initialize everything and then post that semaphore value up all the way up to like 7 or 8. And then each of the threads can go ahead and decrement the value. And now they can all execute their initialize thread function and we're all good. So that was the solution for 7 marks. So now it's your idea. It was just kind of hard to follow. Or the process of getting there, you got to this correct solution, but the process probably confused a bunch of people. So if I wanted to just have one semaphore, I don't use the number of num threads. What I can do is I can place a post here.
That's what I was trying to get at.
Yeah. So in this case, I can put a post there, and what that will do is, well, if any of the threads, 1 all the way to 7, say, try to execute this first, well, they're all going to be stuck on the wait because the current value is 0. Then the only way to change that value from a 0 to a 1 is after thread 0 executes, it would post it back up. So it would change from a 0 to a 1. And then some thread could wake up that was on the wait. Let's say it was, I don't know, thread 3. And then it could get through the wait, so it would change the value from a 1 to a 0. And then we would have it post immediately after to wake up another thread, so another thread can execute. So it would change the value from a 0 to a 1, and that way we could have, thread 3 or thread 2 execute. It would do the exact same thing. And essentially, each time through, a thread is going to wake up another thread until they're all finally through that sem wait, and they can all call initialize thread, and we're all happy, and that works with any number of threads. So questions about that one? All right.
What is the answer back
That,
there? Exactly that?
yeah.
Huh.
I guess we're the last one, so yeah.
Ah.
And the initial value is 0.
I'm not good at explaining my thoughts.
Yeah, it's just confusing. I think you confused everyone. Yeah.
Oh, that's awesome. I didn't have it else.
Yeah, technically you can do that as well and don't have an else. It's just slightly inefficient because thread 0 doesn't need to do that. Yeah,
So basically, wait actually acquires the semaphore and post releases the semaphore, no?
wait just decrements it.
What?
Wait atomically decrements the value. If the current value is 0, it will wait until it becomes a positive value so it can decrement it without going negative.
Uh-huh, sure.
All right. Oh, here we go. Considering the same code, so here's the solution without semaphores. So we have if thread ID is 0, initialize everything, otherwise yield. So assume we have cooperative user threads. So this would be like your lab 4.
3, 4.
So assuming I have your lab 4 implementation, is this a correct solution if we set it up that every thread can go ahead and execute this.
You didn't wait, or no, actually, never mind.
I
Lab
think
4.
yes. Like I remember lab 4, like we only use a queue to like loop through the thread, right?
Yeah, so we got one yes. Anyone
I
else?
think it's yes, just because it's gonna loop back around.
We got 2 yeses. Everyone else peer pressure? Okay, so the answer is yes, assuming we have a FIFO queue and all the threads are just in the queue. So assuming we have a FIFO queue where if you yield, you just go to the back of the line, well, it doesn't matter where thread 0 is in the line. Essentially, every thread is going to be shoved to the back, and then whenever it's thread 0's turn, it is not going to go to the back, it's going to execute first. And because they're all user threads, you have control over the scheduling, so you know exactly what is going to happen. So this would be a valid solution. All right, whoops, didn't see that. All right, so now we have the exact same thing, except now we have cooperative kernel threads running on a machine with multiple cores. Now is this solution correct if we have kernel threads?
What's the difference by the way?
Yeah, so what is the difference between kernel threads and user threads in terms of usability? Sorry?
They could run in parallel.
Yeah, kernel threads can run in parallel, and also, do I have control over the scheduling of kernel threads? Nope. So if this was our solution and they were kernel threads, this would not be a valid solution because, well, even some silly case where like you have core 1 and core 2, well, I could have thread 1 on one, thread 2 on another, and then if these are the only threads on the core, whenever thread 1 calls thread yield, well, the scheduler could be like, well, there's nothing else to run on that core anyway, so I'll just continue executing thread 0, just kind of ignores the call, goes on, continues. They could execute in parallel. Thread 0 could just be scheduled after all the other ones. You don't know, they're kernel threads. So this solution will not work if they are kernel threads, since you essentially have no control over it. Yep.
So basically regarding user threads and kernel threads, like the difference is that like kernel threads are like controlled by the kernel, and we can assume that it may run in a really weird way.
Yeah, kernel threads are controlled by the kernel, so the kernel knows about them. It schedules threads independent of any other thread.
And we don't always know what the kernel, like, how the kernel decides to handle the thread.
Nope, the kernel can schedule it however it wants.
Thank you.
Yeah. All right.
What if you like put like a, you scroll up, so if you put initialize, like you want essentially initialize everything to go first, so you can put like a Boolean flag, not Boolean, but like a flag that says, oh, initialize ran, and then at that point put like thread yield in a while loop, and it's like while initialize ran is false, then yield, keep
Well-
yielding until.
Well, this is a good question someone else brought up. All right, fix this, but with condition variables then. Do you want to do that?
What's the condition variable?
What's a condition variable? Means we should probably know what that is. So condition variables are essentially just like queues, how they work, right? And then there's a signal and a wait, where wait will block until another thread signals you and wakes you up. So do you want to try this with condition variables or go to the next one?
Will it be relevant to the final?
Same.
You should probably know how condition variables work on the final.
Like, are you just saying that, or?
Let's do this quick.
Am I just saying that? I don't. Yes?
So probably have thread 0 signal all other threads, I assume?
Yeah, it could just be the same thing, except if it's the condition variable, you know, we could have some Boolean flag, bool is init something like that. And then some con variable, let's call it cond. Huh? You can include standard bool. Yeah, so in that case, well, we also need a mutex. I think you still have to include that header, but I think that header is defined in C99.
Yeah, the underscore bool only exists in C99 topic.
Yeah. All right, so if we have this, so with the condition variable, we need a mutex because, well, it needs to be protected. We have the condition variable and the is initialized. So in this case, we would have to lock the mutex, then call initialize everything, and then we can set is initialized equal to true. And then unlock and at this point, well, we would probably want to signal a bunch of times. So in this code, instead of signaling up to, I said I wouldn't test this, but in this case, it would be kind of wasteful, so there should actually just be a broadcast here, which will just wake up every single thread. So instead of a broadcast, I could just have a for loop that says for 1 to however many threads there are, call signal that many times because there might be that many threads waiting. So you can assume your question won't look exactly like this because broadcast makes more sense in this case, but broadcast would wake up every thread.
Wait, can't you also, or do you have access to the queue itself? You do, right? You just wait from like...
You do not have access to the queue itself. You just have
you don't have
signal
to link the
broadcast.
queue?
No.
Okay.
So then if we have our, so broadcast on the condition, and then in the else, would probably look like, what does it look like? Lock the mutex, and then while not is init, yeah, then cond wait, I'll just shorten it, so wait with cond and the mutex. And then here I could call unlock, and that would be it. So now in this case, so grabs the mutex, it will check if it is true. If it is currently false, it will wait. So that blocks this thread, puts it on the queue, and also unlocks that mutex. And then whenever it gets woken back up by signal, or in this case broadcast, well, it will reacquire the mutex and then check again and either put itself back on the queue, or it will actually, or that condition is actually going to be true now, and then it would unlock, and then we can go ahead and start executing the rest of the function. So in this scenario, would it be a good idea if I change that while to an if? That is a common trick. Yeah, so this example, probably okay because it just changes once, but in general, it should be a while. And I like the general case because if it's a while, then it works in the condition, then if would work too. But always be a while. All right, 10 more minutes. So any other requests or just flip? All right, yeah. Yeah, if it's kernel threads, you just have no control over it whatsoever. So they could run in parallel. Just thread 0 just couldn't be scheduled until way after the other ones, even if they yield. You have no guarantees that they're kernel threads. All right, threads. Oh, this looks fun. All right, let's do this quick. So this is a super fun threads one. So let's read the code super quick. So we have a global here called array that has an array size. Then we have a global variable called global sum. And then a run function which gets a thread ID and then creates a start and an end index, which doesn't really matter in this case. And then we'll have a variable called local sum. It will increment it and then increment global sum. And in the main, we create num threads, create them all, and then join them all, and then we print off a global sum. So each thread is calculating its own sum of this array and then joining them all together at the end. So, can we see all that, more or less?
Yes.
So this is the main one. So, is there a data race with the variable called array?
I don't think, if I'm reading the code correctly, I don't think you're changing the same index.
I don't think
for
they.
thread, so no.
Wait.
Not changing. All right.
What is the? How do we define arg? Like the TID, the arg after TID.
So the arg after thread ID is here. It's just a unique location for each thread.
Yeah, I don't think there's a data race.
So,
Oh.
There is a race, but not on array.
yeah. So for array,
What he asked for, right?
who remembers exactly what the definition of a data race is?
Two threads try to write. Wait.
Close.
Two accesses where one is a write. At least one is a write.
Yeah, two concurrent accesses where at least one is a write to the same location. So, in this case, do we have concurrent accesses to the array location? Yes.
Same location.
Yeah.
Wait.
Actually, do we?
Actually, no, we don't.
Actually,
No,
no.
we don't.
Okay, so we don't, but even if we did for some reason, we don't have a data race with array because it's only read, it's never written to. So if we only read from it, not a data race. In this case, they're actually all disjoint, but even if they weren't, then we don't have a data race with array. All right, do we have a data race with the local sum variable?
No.
They're all its own.
Because it's local
No, it's local.
to each thread.
Yeah, for each thread. So we don't have a data race for local thread because, well, each thread has its own stack and local variable, whatever I call it, local sum, will be a variable on its stack. So I do read and write to it right here, but I don't have two concurrent accesses to it because it is unique for each thread. So there's no data race with local sum. Is there a data race with global sum?
Probably yes.
Probably yes. So probably yes is you will probably get a mark on it.
So just put a mutex around global sum line and you
Yeah, so
It should be.
there is a data race on global sum. So this location is accessible in every single thread, and we are reading and writing to it concurrently. So we may have a data race. So yes, how would I fix it?
Atomic add. Wait.
Just add a mutex
It-
lock and unlock around it.
Yeah, so just add a mutex, and then I could just do a lock m. Does that fix it?
Assuming n is global.
It should.
Yeah, assuming m, I only define one m, like we have m up here that's like initialized, whatever. So that probably won't get you a grade, but There, close enough.
The question asked to fix it.
Yeah. So the question eventually, so is it necessary to protect access to array? No. Protect local sum? No. Protect global variable? Yes. How would I do it? Several solutions. Easiest that I assume most of you did would just mutex around it. If you said make a atomic int, then whatever. I gave you the grade even though we didn't really talk about them. Yeah.
So if, for example, like my first thought for question 28, was it 28? Yeah, no, 27, I guess. My initial thought was that I didn't think about the right thing yet. I was thinking about, they don't access the same elements. So if you said that, would you still get any marks?
Well, then you'd say no, they don't. They access different elements.
Yeah,
That's fine.
but then I didn't mention the read part. I mean the write part, which is like I didn't mention that they only.
Well, if they only access their own element, doesn't matter if it reads or writes. It's,
so
if
you
it's
get the mark either way.
yeah, if it's unique, then even if it's reading or writing or reading whatever, it's fine, right? All right, last one was, if the threads were changed from joinable threads to detached threads, would this lead to any issues?
What is the detached thread?
Uh-oh.
I'm waiting on
Anyone help? What do detached threads mean?
Kids die on the
They, oh, they die.
Yeah, they just, whenever they're done executing, they're just, so detached threads mean I cannot join them. So if I had detached, essentially that line is gone, and I have a
Detach.
detach here. So what issues would that lead to?
you could print global sum too early, or every sum.
You detach all of them and never join them, they just immediately return to the beginning and die.
Yeah, so what's likely going to happen is, well, I just create all the threads and the main thread just continues on executing. It prints global sum. Global sum is equal to 0. It returns from main, which is the same as calling exit. Process is dead. All the threads are dead, so nothing actually happens. Or could also be the case because you don't know how they're being scheduled, where like one thread adds to global sum, and then we get like a partial result here, and then the process dies, or two go and we get a partial result and then it dies, so on and so forth. So any questions about that? All right, anything else for the last 3 minutes?
You could fix that with like just a line where it tells you like in wait for everything, right? If you were to detach them.
Yeah, well, in this case, if they were detached and I wanted to print off the global sum, well, I can't. I need them to be joinable because I need to make sure that they're all done.
Wasn't there a way to kind of wait for a detached thread?
There is a way to make sure the process didn't die until all the threads were done. So if I ran pthread exit here instead of letting it exit, then my main thread would exit and all the other ones would eventually finish, but doesn't really matter in this case because sure, the global sum is eventually right at the end, but no one's ever going to print it. So I'm never going to see it anyway, so probably better off that the process dies anyways.
What if you put it in a wrapper and then did thread exit and then print it? No, but it's still, what if still?
All right, let's see if we can speed run anything. Oh, there, this,
This is literally the function, pthread exit.
oh, won't have numbers for this, but we can continue on with this file system question if you want, because guess what? You'll have file system 1, so yay. All right, so if you have any other questions or anything you want me to cover, please post it in the section 3 Discord channel and we'll do it, I guess, tomorrow.
What's happening to this file system question?
We'll figure it out next time. All right, just remember, pulling for you, we're on this together.